we ran across a little interesting phenomena regarding the word miscible, and I really like this. I really like the term, and so I tried to explain what exactly this is, and you can take a half a cup of water and a half a cup of alcohol, and what would you expect if you poured one into the other? How much volume would you see on the measuring cup? Well, if you do this, you see it doesn't equal a cup at all. It's clearly not a cup, and it's not a magic trick. So this is kind of unusual. You probably haven't seen this before. This phenomena. But in explaining this, what's going on, you start at the level of the atom. We have the nucleus, say the size of a tennis ball, and first electron in its orbit is maybe, can't remember the estimation. I don't know if it's 100 yards and the size of a pinhead, or maybe further out. But there's this space between the nucleus and the electron and all the other electrons as it goes out, and that space is maintained. The electron will not come to an orbit half the distance. If you were swinging a tennis ball around your head on a string, you could pull it halfway in. You could pull it at 0.499 of the distance in, or 0.4998 of the distance in a continuum. But you can't. Electrons can't do that, and they have specific orbits that they populate, and this is a very interesting phenomenon, that there's no physical structure there, like a stairway or a brace or a support holding it out there, and yet, so there's not a continuum, and then in the nucleus, of course, which is much larger, is composed of neutrons and protons, and the protons are positively charged and the electrons are negatively charged. And how is it that they don't just come together? Well, I guess we don't need to know that, what we're talking about. It is very interesting, but so you have the atom, like a hydrogen atom, and then if you bring two of these atoms together, there are certain rules or phenomena of nature that allow these two atoms to bond. So then you have a molecule. So we've gone from the nucleus to the atom structure to the molecular structure now, and all atoms have certain rules of how they combine with other atoms to make molecules. And of course, there's a lot of space, again, between atoms themselves. and the rules, each atom has a different capability to bond with other the capabilities of other types of atoms. And then the molecules bond with themselves. For instance, in water, which as a molecule, you have the H2O, so you have three atoms combining together, and they all have space internally, and then you have H2O that combines, that adheres, the molecules adhere to themselves, and so you have things like water droplets. We put a drop of water on a piece of greasy surface, and you'll see it beads up, or you put water in a glass, and you'll see the edges. You'll see a curve there, and so what you're seeing is that the water molecules are adhering to the glass molecules, and also the water molecules are adhering to themselves, and those are two different forces, and they create different edges around the edges of liquids and solids. So that's when they're liquids. And then, of course, so the molecules bond in certain ways when they're liquids, and they have all that space. And then with solids, of course, things become rigid, and the structure, there's now a structure, a physical structure of rigidity, where the molecules within the sample don't move. They do vibrate, but they don't translate over distances like they can in a liquid. Well, you know what I'm talking about. And then a gas, of course, the molecular forces, break down further. Well, getting back to the molecules, when you have a bunch of water, isn't that a scientific term? Well, I mean, if you were a florist, anyway, if you have this cup of water, and you have this space between the molecules, you have H2O atoms, molecules, and then you have the various H2O molecules floating around, and there is space between them. Well, alcohol has different atoms grouped together, and they have different rules and ways and spaces that they have between their individual molecules. And when you put them together, it's kind of like taking one hand with the other, and you press your fingers together, and they go in between each other. And that's what happens when you have water molecules and you put them together with alcohol molecules. They slip together, and they don't take as much space up as if they were one cup each. The physical space isn't necessary. Anyway, that is what's happening, and that phenomena is when two. So anyway, that's the phenomena when two liquids are miscible. I often think of couples, that two people are miscible. they fall in love